Alright, now let's look at the core of our genetic algorithm, the function breed new population. This is where we decide who get to survive and who gets to become parents for the next generation. We will create this list of person, our sorted list. First we will sort the current population based how long each person will be survived. This one who will die early first, and the one who will live longer at the least. We are using order by desync, this function for ordering using system.link. Since we want the best perform, we actually take the one the end of the list. Second, we will take the only the top and the half of the population. These are the survival longest. This become the parent of the next generation, and we take it already the half of the sort population. Uh, we already cleared the list of population here after we sorted, and we will create another list. It will be list person, the parent, also sorted population, and take the half count of sorted list. Then we will take the count of the parents using parents.count. Let's make for each to throw all the parents. Before that, let's create a function return the person. We'll call it breed. It's take two parameter. We'll take person one as a parent one, and another parameter it will be person two, the second parent. This function will, as we mentioned, it's return person. This person dot child of it will be instantiate the person again. We are using the prefab again. After that, we will change the position of the child using child to transform equal a new vector 3 x-axis as before, along the to keep a line up in the scene. Then we will create DNA child DNA child DNA equal new DNA. After that, we will otherwise, we go with normal inheritance for each traits, red, green, blue, and size. We randomly pick from either parent to simulate genetic crossover, like how the kids inherit traits from both parents. We already using random.range. If equal 0, 0, if equal 0, it will take from parent 1 current DNA for R, either parent to the current da.r. In TimeSync, we will implement this for R, G, and P, and S. Okay, now G, child, okay, duplicated. B, same thing. Also B here. Also GB here, S also, and S, and S also here. Now the child DNA, it's finished, and increase the x-axis as usual. Now child will set DNA, will assign the DNA, then we will assign also the size and the color as before in first initialize. Okay, this function need to return. Let's make some small refactoring here. No need to call this function. Just convert it to private, and we will call this function inside the set DNA. We will set the color and the side and the color and the size inside the set DNA. Let's back here. Set DNA, it's enough. Also here in first initialize, same thing. Breed function need to return value, return child. Now we don't have error. Population, we add population and breed this function. We already stored the number of parent variable called j, then we will loop through each parent using index j, but there is a trick here. For every I, we also pair with parent to another end of the list using j minus 1. So basically, the first parent is paired with the last, the second paired with second to last, and so on. Then decrease the j minus minus. Inside the loop, one child will I, mom, and j will be dead. Then we will destroy old one, the old the parents, the old generation, using for each for inside the population. Destroy parent dot game object. Now. Now I think everything, and we will increase the generation plus plus, and so we need the time for the trial. Let's private float labs equal 0 0, and in update function we will increase it plus equal time to delta time. If elapse bigger than trial time, we will call our function breed new population. Then we will elapse time reset it to 0 again. Also we'll reset x-axis to -5. Then we will to save this our code and try if it will work or not. Now compiling and just to play, and we will hit our character. Okay, and time it's finish, and again it will be a new generation at hit, also hit. Now everything work fine. Next we decide if this child will be mutation. There is a small 0.5% chance that a mutation will happen. Will random.range 0, 1000 less than 5. This keep thing interesting to add variation over generation. Else it will be else it's normal state about inheritance. Here we will take same random value, just replace DNA with child DNA. Now we have mutation. Just save. Now we try to hit the character. We hit first different character. We will try to keep blue lasting. As you see now, a little bit now blue it's appear more and more and more. There is Now we have all of them. It's like blue. Next, let's try to change the time of trial and make it 8, maybe just for testing. And now let's to show UI using this function on GUI. We will create GUI style equal GUI GUI dot font size, and the color also will be white, and GUI label new rect, and this try this size and height, and the text will be generation. We will show the generation number here, and then we'll add the GUI. Let's rename the GUI and make it GUI style. It's more clear, I think. Duplicate this line and just change the Y and trial UI trial time, also trial here, elapse casting to integer here, and then try it again. I think keep it 10, it will be better. Just to try it, first we hit the red color again. I can hit randomly, then here we go. Now we have a little bit, we are trying to keep the green alive more, the dark green. Now as you see, now we have a generation more green. Now we have a 5 green here, and again in in 6 generations, it's all of them it's green and the small. Now let's try to also green. We have just the green, and now also green and the green and the green. That's how it's work. Green. And now we try to keep the biggest person with the green again. Now as you see, time over time, we have a green person with big. Now as you see, now big, we try to keep the big alive. That's our algorithm. It's work fine here, and now completely we have all big greens.